Welcome back to Chapter 8. Today we're going to look at Section 8.3, which is the inverse of a square matrix. The first thing we're going to look at today is finding an inverse matrix. Now, the definition of an inverse matrix says if matrix A, and I apologize, this should be matrix A times matrix A inverse, equals matrix A inverse times matrix A, which equals the matrix I sub n, where I sub n is the identity matrix. So if this is true, then we say that A inverse is the actual inverse of A. For the first note that I want you to make, I want you to know that not all square matrices have an inverse. And if you recall, a square matrices was something like if we had 3 equations with 3 unknowns, 2 equations, 2 unknowns. And then the second thing I want you to know is if we have a non-square matrix, these do not have an inverse. So if we look at example 1 says to show that B is the inverse of matrix A. And we're given the 2 matrices A and B. In order to show this, we need to show that if I take the product AB, that this has to equal BA, which in turn has to equal the identity matrix. Now the identity matrix for a 2 by 2 would equal 1, 0, and 0, 1. So let's prove that right now. The product of matrix A times matrix B is equal to a -1, 2, and -1, 1 times 1, -2, and 1, -1. And if you recall from section 8.2 where we dealt with multiplying matrices, we have to go the first row by the first column. And when I do that, that's going to give me 1. Then I'm going to go the first row by the second column. This here was going to give me 0. Now I'm going to go the second row by the first column to give me 0. And finally I'm going to go the second row by the second column, and this will give me 1. So far I've produced the identity matrix. Now let's look at the product of matrix B times matrix A. So now I'm going to reverse the order, and I have 1, -2, 1, -1, and I'm multiplying that with -1, 2, and -1, 1. In this here, when I go my first row by my first column, is going to give me 1. First row by my second column is going to give me 0. My second row by my first column is also going to give me 0. And finally, my second row by my second column is going to give me 1. So because I was able to produce the identity matrix both for the product of AB and BA, this tells me that B is the inverse of A. Earlier we mentioned that not all matrices have inverses. However, if a matrix does have an inverse, this is called an invertible or a non-singular matrix. If the matrix does not have an inverse, it is called a singular matrix. And if a matrix has an inverse, then we say that the inverse matrix is a unique or specific inverse for that particular matrix. For example 2, we want to find the inverse of A. Now, for the purposes right now, what I would like you to do is I would like you to just set this up, okay, and then I will show you in class how to do this in your calculator. The first thing we're going to do is we're going to rewrite our coefficient matrix, which is what was given. So I have 1, 4, -1, negative 3. Now I know that I have to multiply this by some matrix, and when I multiply these two 2x2 matrices, I know that I have to get the identity matrix in order for this to work. So I'm going to set that equal to 1, 0, 0, 1. So this is my A matrix. This here would be my identity matrix, and I'm going to call the unknown matrix X. And just for general terms, I'm just going to call this X1, Y1, and X2, Y2. So for work, this is what I would like to see you show for now. When you type this in your calculator, and again, I will show you how to do this, you will find that matrix A inverse is actually equal to a negative 3, negative 4, and 1, 1. For those of you that remember how to do this in your calculator, remember that you just have to go in and enter your A matrix in as matrix A, and then you actually have an inverse function on your calculator. Like I said, if you can't figure this out, though, we will go over this in class. For example 3, it says find the inverse of matrix A. Now this time, matrix A is a 3 by 3. So what I'm going to do is I'm going to do the same approach, and I'm going to rewrite my coefficient matrix, which is 1, negative 1, 0, 1, 0, negative 1, and 6, negative 2, negative 3. I'm going to multiply it by another 3 by 3 matrix, and this is going to equal the identity matrix for a 3 by 3 is going to be 1, 0, 0, 0, 1, 0, and 0, 0, 1. And again, this would be my matrix A, X, and then my identity matrix. And in this case, because I have, for my matrix X, because I have 3 equations with 3 unknowns, I'm going to plug in X1, Y1, Z1, X2, Y2, Z2, and X3, Y3, Z3. When I go to solve this, I will see that A inverse is equal to a negative 2, negative 3, 1, negative 3, negative 3, 1, and negative 2, negative 4, 1. One last thing I want to mention, we can actually show this matrix here with their identity matrix as an augmented matrix. Now we can do it as a multiple augmented matrix, and to do that I'm going to take, so this would be our augmented matrix. Okay, and this is more going to be for next week when we have to do this, but I just at least want to show you how to do this right now. We're going to take our matrix A, so my 1, negative 1, 0, 1, 0, negative 1, 6, negative 2, negative 3. And remember, with the augmented matrix, we're going to do the dots, and then I'm going to put my identity matrix, or this matrix right here, and I'm going to put it in as a 3 by 3. So I have 1, 0, 0, 0, 1, 0, and 0, 0, 1. So this here would be the augmented matrix for my matrix A and my identity matrix. In the case of a 2 by 2 matrix, and this only works for a 2 by 2 matrix, we can tell whether or not a 2 by 2 matrix has an inverse just by looking at the determinant. Okay, and the determinant of a 2 by 2 matrix says, or first of all, if you calculate the determinant and you get 0, then that tells us that there is no inverse. Okay, if you calculate the determinant and you get anything other than 0, then that tells us that we have an inverse. And if I'm given a matrix, let's say matrix A is equal to A, B, C, D, and I want to find the determinant. The determinant of matrix A is going to equal the product of my diagonals, so AD, and I'm going to subtract the product of the opposing diagonal, which in this case is going to be BC. And again, if I take AD and subtract BC from it, and I get 0, that tells me I have no determinant. If I get anything other than 0, then I will have an inverse matrix for this 2 by 2. So example 4 says, does an inverse matrix exist for the following? Now A, we're going to look at the first diagonal, which is 3 times 2. So I have 6 minus, and I'm going to look at the opposing diagonal, which is negative 2 times negative 1, or 2. And this is going to give me 4. And because I got an answer other than 0, then that means yes, A inverse exists. Okay? Likewise, if I come down here and look at B, I'm going to look at my first diagonal, which is 3 times 2, or 6, and I'm going to subtract the second diagonal, which is a negative 6 times a negative 1, or a positive 6, and when I subtract these two, I get 0, and because I got 0, then I can say no, A inverse does not exist, or DNE. The last thing we're going to look at out of section 8.3 are systems of linear equations. Now, if you take your coefficient matrix of a system of equations, okay, first of all, it has to be a square system, whether it be a 2 by 2, a 3 by 3, a 4 by 4, regardless of what it is, it has to be square. If this square system is invertible, okay, then we say that this system has a unique solution. Okay, and if you think about that, when you look at your systems of linear equations, you're only going to get a point of intersection at most. So that means that there's one solution. Now, the linear system has the form AX equals B. Okay, and in order to solve for the variable matrix, we need to isolate the x. So I want to get this x here. And by doing that, I'm going to take the inverse of A and multiply it by matrix B. So let's go ahead and look at an example on how to do this. Example 5 says you are going to invest $10,000 in AAA rated, AA rated, and B rated bonds, and you want an annual return of $730. It tells us that the average yields are 6% for the AAA bonds, 7.5% for the AA bonds, and 9.5% for the B bonds. You want to invest twice as much in the AAA bonds as in the B bonds. First of all, we need to write a system of equations to represent our investments. So the first thing I'm going to do is I know that x plus y plus z, x being my AAA, y being my AA, and z being my B bonds, is going to equal my total amount that I have to invest, or my $10,000. My second equation comes from the interest that I want to earn. I see that I have 0.06x plus 0.075y plus 0.095z, and this is going to equal the total interest, or $730. Now my final piece says that you want to invest twice as much in our AAA bonds as you do in the B bonds. So what this tells me then is really my x equals my 2z. So if I rewrite that, where my coefficient or my variables are on one side, I'm going to say x minus 2z is equal to 0. And now I have my system of 3 equations and 3 unknowns. To write this as a matrix, or in a matrix setup, we are going to write our coefficient matrix A, which is going to be 1, 1, 1, 0.06, 0.075, and 0.095, and then 1, 0, negative 2. So this is matrix A. My matrix X is going to be my 3 variables, or x, y, and z. And I'm going to set that equal to my coefficient matrix, or I'm sorry, my constant matrix. And this is what I'm going to call matrix B. And I have 10,000, 730, and 0. Now to finish solving this, I know that if my equation is AX equals B, if I want to solve for this x here, then I'm going to have to take and isolate x and go A inverse times B. And again, I'll show you how to do this on your calculator if you don't recall how to do that. But when I go A inverse times B, you will find that we get a matrix X is equal to 4,000, 4,000, and 2,000. So just as a quick check, 4,000 plus 4,000 plus 2,000 equals the original 10,000 I invested. And this then tells me that I have 4,000 invested in the AAA bonds. I have 4,000 invested in the AA bonds, and 2,000 invested in the B bonds. And that concludes section 8.3.